I'm Eelco van Kampen, the Isogarching. You heard me talk lots on Monday and Tuesday already. Yesterday at the Mentimeter session, we heard that that we want a census of cluster galaxies. So this post is about how we might be able to do this with ALMA, how to build up a sample of cluster galaxies. And there's various ways of doing that. I'll just keep talking.
Yeah, keep talking. I will fix it.
One is to just point at known cluster galaxies, and we've seen lots of talks today that exploit this. Allison's review and Minju's talk. Another way would be to do a blind survey, of course. That would be preferable even, but that's very expensive, obviously, because ALMA is not really a survey telescope. And the poor man's choice is the one I highlight here, is to just collect data from the archive. The ALMA archive is building up nicely. There's lots of data in there. And as an example, I'm showing you the clustering cosmos that Meng Yuan already talked about. I'm not done yet, Helmut.
Yes, sorry, my laptop is getting crazy.
That's fine. So the cluster Meng Yuan talked about has some other pointings nearby from other projects, and one can actually combine these if they overlap both spatially and in frequency, and then build nice maps where you actually extend beyond the original project. So that's what I'm trying to do as well. Okay. So have a look at the poster. It's I think it's D9, right?
Okay, I guess I'll just get started. So hello, everyone. I'm Joe, and a big thank you to the organisers for putting on such a fantastic conference so far. So I'm a PhD student at Imperial College London, and my poster is based on some of the work we've been doing on the massive Redshift 1.6 galaxy cluster SpARCS GCF2021. So in this project, we basically aim to map out star formation in a wide region across the cluster to try and better understand how this evolution from high redshift star forming protoclusters to more local massive and quiescent galaxy clusters proceeds. And in order to do this, we basically build up to kind of 20-band photometry for the spectroscopically confirmed cluster members. And we also use the SED fitting code EASY to try and identify some additional cluster candidates. And then we use the photometric fitting code SIGAL to estimate the properties of these galaxies. And what we find in our preliminary results is that they're pretty consistent with kind of a gentle increase in star formation with projected cluster-centric radius. And we also see some hints of potential substructure. And we also find that the star formation rates of our cluster members are broadly lower than the kind of comparison field sample. So if this sounds interesting to you and you want to hear more, feel free to message me on Slack or come and see my poster at A8. Thank you.
So my poster is about the evolution of mass size relation in CARLA clusters. I will briefly explain you what CARLA is. We have, as in previous talk from Jaslene, we have also isolated our clusters based on Grism spectra, and then amplified this with over-densities in photometric redshift. So we have clusters at approximately redshift 1.5 to 2. And the main result from, well, that I want to present to you is that the mass size relation in cluster, well, it is apparently the mass size relation for passive galaxies has approximately the same slope and a very close intercept to this on the field. But on the other hand, we observe a lot of compact galaxies and especially low mass compact galaxies that are unresolved in HST and that are at approximately mass logarithm of mass 10. They're very small and they probably represent a population that hasn't experienced much of size evolution in its life.
Hello everybody, I'm Andrea Biviano. I'm an old astronomer at the INAF Trieste in Italy. And in fact, I'm actually older than the right-hand side elephant in this slide. My claim is that clusters are like elephants. They reach their final structure when they are only 1/5 of the final age. Even if their mass, or if you wish, their tusks, in the analogy with elephants, they keep growing considerably. So this conclusion is basically based on the analysis of 14 clusters of redshift between 9.9 to 1.4 from the Gauguin survey. And the mass profile is similar in shape to that of more aged clusters, and in fact also their velocity and isotropy profile. That is, basically the orbits of cluster galaxies do not appear to evolve with time. My poster is A4, and I wish to congratulate the organizers for this fantastic meeting. Thank you.
Yeah, thank you. Greetings from Santiago. I'd just like to point you to B15, which is the ALMA observations of a protocluster candidate from the Planck Herschel program, already discussed by Hervidol in B1. Going anti-clockwise on this slide, there's the Planck all-sky color selection, and then there's an elongated structure with 8 bright peaks in Herschel, which were the targets for the ALMA pointings, finding 18mm galaxies. The Herschel sources can consist of 1 central, but also up to 4 individual galaxies. Going to the mid and near infrared, there are 2 red sequences, and Maripolletta fitted SED templates for photoset and also these galaxy properties here, revealing 2 redshift structures, one at 1.5, confirmed also with CO, and one at 2.4, much in line with the Lean-Godin simulations. Most of the galaxies, particularly at low set, are star forming on the main sequence, while at higher redshift, there's more scatter also with starbursts, which could indicate a less evolved state. There's more detail also on star formation efficiency, stellar masses, and gas fractions. So if you're interested, please talk to me.
Hi, I'm Andrés Laza. I'm a master's student at the University of La Laguna in the Canary Islands in Spain. The poster I'm presenting is my master thesis, where I've taken an image of the Spiderweb galaxy and surrounding from the SCUBA-2 Ruediger large program. I'm analyzing it together with a multi-wavelength dataset that goes from the near infrared to the radio range. The objective of this project is to look for new members of the Spiderweb Protocluster in the region. At the moment, we have already achieved some interesting results as observing new, never seen before galaxies in the field. If you want to know more about it, my poster is at B17. Thanks.
Hi, everybody. My name is Brian Lemaux. I'm a researcher at the University of California, Davis, working with Lori Lubin, Olga Kuchiadi, formerly Olivier Lefebvre, Denise Hung, who's going to give a presentation next, I think, and Lu Shen, who gave a poster on Monday, among others. And we work on the optical near-infrared characterization and detection of overdensities between redshift 2 and 5 with the VMOS Ultra Deep survey. And this is in conjunction with our new survey called C3VO, which uses new Keck, Mossfire, and Lemaux observations, and our redshift 1 clusters and groups survey called Or Else, which Allison mentioned in her excellent review talk this morning, to constrain galaxy evolution in overdense environments from redshifts 1 to 5. So if you're interested in that, if you're interested in our result on the reversal of the star formation rate density relation, which Julia mentioned yesterday, or the efficacy or accuracy of our method, please come see any of our posters or talk with us on Slack. Thank you.
Hi, I'm Denise. I'm a grad student at the University of Hawaii. My poster is over finding structure with optical and near-infrared data using Voronoi tessellation as a density field estimator. So the main advantages of Voronoi tessellation is that it's scale independent and doesn't make any assumptions about structure morphology. So we first found a few hundreds of candidate structures in a serendipitous search of the Or Else fields at about redshift 1. And we also used these candidates to derive a mass function, which with purely optical data has only been done before with the local universe. So we're currently working on looking for structures in the higher redshifts of 2 to 5 with the C3VO survey, which from preliminary results, we've found just over 300 candidates so far. If you'd like to know more, please talk to me.
So, hi everyone, my name's Ian McConachie. I'm a graduate student at UC Riverside, where I work with Jillian Wilson and the magazine Survey. I study the environments of ultramassive galaxies using a combination of deep photometric catalogs and spectroscopic observations taken with Mossfire on the Keck telescope in Hawaii. I'm presenting poster C5 on a spectroscopically confirmed protocluster we have discovered around a quiescent massive galaxy with another nearby post-starburst massive galaxy and associated overdensity. The protocluster has an elevated quiescent fraction, particularly on the high mass end, which could indicate early mass quenching in dense environments very early on, rather than the more mass independent environmental quenching seen in low redshift clusters. So come on by poster C5 and take a look, or send me a message on Slack.